Hi guys, welcome to this set of videos. These videos are going to follow along with the notes where we're now going to begin to take a look at transversals. Transversals and how those transversals cut across parallel lines, and really what we're going to look at is the types of angles and the relationships that are formed when you have a transversal that intersects parallel lines. And I know that's a gigantic mouthful. What I just said probably doesn't make a lot of sense. I promise it will. Hopefully it will by the time we get to the end of this set of notes. So there's not really a whole lot I can say until we get a chance to start talking about it. So let's just jump right into it. As always, with a set of videos and a set of notes, we have an essential question. This is the question you want to be able to answer by the time we get to the end of this section. And I've got that essential question for us right here. Let's go ahead and highlight it as we take a look at it. What you'll need to be able to do is how can you prove and use theorems about angles, so we're still talking about angles, but angles that are formed by transversals that intersect parallel lines. And so there they are, a whole bunch of words in there, transversals and intersecting parallel lines. We're going to form angles. What does all this mean? Well, what we're going to do, right, because I'm using probably a bunch of terms you guys have never heard before, right? So we're going to, as we go through this set of videos, right, we're going to talk about a number of things together that you need to know in order to help you answer this question. Those are going to be our objectives. So the first thing we're going to do is take a look at theorems about angles formed by transversals that intersect parallel lines. So we're going to talk about what is a transversal, what are parallel lines, and if you have a transversal that intersects parallel lines, what kind of angles are formed. So we'll go through all of that vocabulary together so that we can communicate clearly and you understand what I'm saying. Of course, then after, right, we go through all that introductory stuff, boom, we're going to use that to solve problems, right? This is math. That's what we do. We solve problems. So let's just jump right into this. Here we go. Parallel lines. Now, parallel lines I think is something you guys are probably already familiar with, or at least I hope you are. If not, here's what we're talking about. Parallel lines are going to be two or more. I know I have written here two lines. It doesn't have to be two lines. In fact, based on the diagram I gave you, right, it's possible for it to be more than two lines. But anyway, two or more lines in a plane that never meet. All right, so parallel lines are lines that never touch each other. They never intersect. They never meet. Okay, now the way that we're going to write that, remember, geometry is its own language. You need to be able to speak the language, but you also need to be able to write and read the language of geometry. And here's how we write and read that, right? So what I've got is parallel lines, line AB, right? Because remember, when you've got the bar over top with the arrow on both ends, that means a line. So line AB, the double sort of line, right? Parallel lines, because those lines aren't touching, they're not intersecting, so it means parallel lines. In fact, let me write that for you right here. That's my highlighter, that's not what I want. That guy right there means parallel lines. So I have line AB and line CD are parallel lines. If you ever have parallel lines and you want to write it, that's how you'd write it. If I'm telling you have parallel lines, you need to be able to read this and go, oh, based on that, I know that line AB and line CD are parallel, meaning they never touch or intersect. Now, in a diagram, there's a way that I'm going to show you this. So you can never assume, right? In geometry, you never ever assume that a picture is drawn to scale. Even if it looks like lines are parallel, you cannot make that assumption unless I tell you. And there's a couple of ways I could tell you that. I could tell you by stating line AB and line CD are parallel. Now you know in the diagram those lines are parallel. So let's just say that this one right here, this is line A, B, C, D, right? So now you know, based on that description, those two lines are parallel. They never intersect, they never meet. The other way I could tell you that is by what's drawn here on the diagram. We're going to use arrowheads to indicate that lines are parallel, right? So AB and CD are parallel lines. I do that by putting that little double arrow on them, right? Because they have matching indication marks, we know that those are going to be parallel lines, as opposed to line A, B, and C, which all have just a single arrowhead. What that tells me, line A, B, and C are all parallel lines. They never touch, they never meet, but they're not parallel to A, B, and C, D, because those guys have two of the little arrowheads. All right, so really what it is it works just like this. If I had, we saw this before in a previous chapter. Actually here, let me make that one a little bit shorter. Here's what we're gonna have. Yeah, that's better. Yeah, that's better. I like that. So there's point A, B, C, and D. The way that we did this in a previous chapter was if this segment and this segment were congruent, they were the same, we would put a little hash on them, right? Well, same thing here. If these lines are all parallel, we'll put that little arrowhead on each of them showing that they're parallel lines. But these two segments, while they are congruent, they are not congruent to this one and this one. But those two segments are congruent, so the way that we did that was we put a double hash on those guys, right? That tells you that these two segments are congruent, they're the same, but different than these two segments. So we do the exact same thing with parallel lines. Since these two lines are parallel, we put the double arrowhead on there. It tells me those lines are parallel, but they're not parallel to the lines that have the single arrow on them. All right, so just a little bit about notation, the way that you read, write, and speak geometry. Again, it's a language we need to be able to communicate. I do talk here about skew lines, so just real quick, introduce it to you, and then we'll move on because we're not really going to do a whole lot with skew lines here in this section. I just want to mention it. Hopefully what you can see is I've got a cube drawn here. So skew lines are going to be two lines that are not in the same plane, but still are lines that never intersect. So hopefully you can kind of put your 3D brain on, right? If this is a three-dimensional cube, what you can see is that line AB, which is on that back edge of the cube, right? If I were to extend that guy, which is on the back edge of the cube, it would never, even though it's on a different plane than line CD, they're still never going to intersect because line CD is on the front edge of the cube, right? So if I were to take this cube and spin it towards you, right, line AB would be coming at you, line CD would be headed off at an angle like this. Those lines would never actually intersect, even though they're not in the same plane. So line CD takes off like this, and I know the way that it's drawn, right? It looks like they're intersecting lines, but you have to, again, 3D brain, thinking three-dimensionally, right? This one is on a different surface of the cube than AB is, and so they don't actually intersect, right? I'm just trying to draw something 3D on a two-dimensional surface. So it looks like they intersect, but hopefully you can sort of picture in your mind using sort of 3D brain that they wouldn't actually intersect because CD is on the front edge of that cube, while line AB is back here on the back edge of the cube, and so as those lines extend out to infinity, there'll always be a gap, always be a space between them. They never intersect. So anyway, that's skew lines. All right, here we go. Let's talk about transversal. It's really, really simple. A transversal is simply going to be a line that intersects, right, two or more parallel lines. So a line that intersects two or more lines in a plane. Very, very simple idea. Here's what you've got. I've got two different diagrams for you. I have two lines in a plane, and I have a transversal, a line that intersects both of those lines in a plane. Same thing over here. I have two lines in a plane. My transversal is going to cut through those lines, is going to intersect those two lines. So both the lines right here in red are my transversals. Oh, that's my highlighter. I just want my red pen. Transversal, transversal. transversal, all right? So those are my transversals. That's all it means, right? If you just have, again, it's a line that intersects two or more lines in a plane. Now, what you can see from my diagram, right, is that when that transversal intersects those two lines, when that transversal intersects those two lines, a number of angles are created. I've numbered them. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Turns out there are some interesting relationships, right, between those angles. So let's go ahead and talk about their names first. How do we name them? Because we need to be able to communicate what angle we're talking about. Then we'll talk about the relationships between those angles. So here we go. Up first, let me do these ones in yellow. Exterior, oh, that's my pen. I want my highlighter. There we go. Oh, I still have my pen. Jeez, struggling today. There's my highlighter. Okay, so exterior angles, angle 1, 2, 7, and 8. Let's just jump back up here. Where are those angles? There's angle 1, 2, 7, and 8. So 1, 2, 7, and 8. Exterior, why? Well, what you can see is of all of the angles I've got, right? 1 and 2 are on the outside edge, 7 and 8 are on the outside edge, right? These would be your inside angles, these are your outside angles. We just use the word exterior instead of outside because exterior is, I don't know, a little bit more grown-up, adult, high school word, right? So 1, 2, 7, and 8, exterior angles. Same thing over here, 1 and 2, 7 and 8. Still exterior angles, 1, 2, 7, 8. Those are my exterior angles. Now, I got another one for you here. Alternate exterior angles. We'll do those ones in green. Alternate exterior angles should be a fairly simple idea. We're talking about exterior angles that are opposite of each other, right? So, 1 and 8 are alternate exterior angles. They're opposite each other. They're both exterior angles, but they're on opposite sides of the transversal, right? 1 is on the left-hand side of the transversal, 8 is on the right-hand side. Check this out. 7 and 2. Alternate exterior angles. They're both on the exterior, but they're on opposite sides of the transversal, right? Should make a lot of sense. Same thing over here, 1 and 8. Alternate exterior, 7 and 2. Alternate exterior angles, okay? Actually, a great idea, probably one of the really good way to sort of memorize these, because again, in order for us to communicate, right, you need to know what I'm talking about when I say something. So when I say, hey, these are alternate exterior angles, you got to know what I mean. A really good way to learn these is to do flashcards, right? These work really well for flashcards. Just put exterior angles on one side, right, with a diagram, and see if you, as you go through those flashcards, if you can name what those angles are. So this is a great way to sort of set up flashcards and just keep going through them until you've learned them. Here we go. I need, actually here, let me erase. Oh, is it gonna let me? Oh no. Nope, won't. Okay, so I need a different color. Let's go. I haven't used red yet. Interior. No, here, yellow. Interior angles, well, this should be fairly simple, right? If exterior angles are the ones on the outside edges, right? Outside edges, interior angles have to be the ones on the inside edges. So we have 3, 4, 5, and 6. 3, 4, 5, and 6, right? 1 and 8, 7 and 2. Okay, cool. So there we go. I've got my interior angles, 3, 4, 5, and 6. No big deal. Again, exact same thing here. I can have alternate interior angles. Those are going to be angles interior, on the interior, but on opposite sides of the transversal. So 5 and 4, 3 and 6. Same thing over here. 5 and 4, 3 and 6, right? Alternate interior angles. So again, just a real simple idea. Either they're exterior angles or they're interior. We can go farther by describing them as alternate exterior or alternate interior. Not that big a deal. And then here we go, the last one. Sorry, not the last one, but we're getting close. Consecutive. Consecutive interior angles. So consecutive interior angles are simply going to be this. They're angles that are on the same side of the transversal, but they're interior angles. This is a really, really simple idea. Here we go. These are my interior angles. Instead of the alternate interior, I want the same side, or what we're going to call consecutive interior angles. That would be 6, 6, and 4. 6 and 4, same side or consecutive interior angles. 3 and 5. 3 and 5, consecutive interior angles. Same thing over here. 5 and 3, consecutive interior angles. 4 and 6, consecutive interior angles. Right? So I know there's a lot of vocabulary here. There's a lot of terms that you have to remember, but hopefully, right, they make a lot of sense. Like, it's not really that complicated once you've seen it. It's either exterior, it's interior, they could be alternate, they could be consecutive, same side, right? And then finally, our last one, corresponding. Let's see, can I find, do I have a different color maybe? Did I already use blue? I think I already used blue, but we can go back to it. Yeah, blue. Corresponding angles, this is going to be really, here's the idea. These are going to be angles that occupy the same position in different intersections. Here you go, piece of cake. You're going to like this. Here's what we've got, right? I have an intersection right there. I have an intersection right here. Those are two different intersections. So, corresponding angles are going to be angles that occupy the same position, but in different intersections. So, here we go. My corresponding angle, right? Corresponding angle 1 corresponds with 5. Why? In this intersection, 1 is in the top left corner. In this intersection, 5 is in the top left corner. Right? That's it. Corresponding angles. They're in the same position in different intersections, right? 4 and 8. Corresponding angles. 4 is in the bottom right-hand corner. 8, bottom right-hand corner of different intersections, right? I'll do that one in green. 4 and 8, right? Those are going to be corresponding angles. I can do the exact same thing over here. 1 and 5. Corresponding angles. They're in the same position, different intersections. I could do, I don't know, how about 2 and 6, right? 2 and 6. Same position, just different intersections. Once again, guys, I know that there's a whole bunch of terms and stuff here. I know it seems like a lot. Hopefully it makes a lot of sense. Keep going through these until you're confident with it. And again, we're going to do a lot of example problems, and the more example problems we do, the more and more comfortable you'll become with these terms. So, head on over to the next page of the notes. We'll take a look at a couple of example problems together. I'll meet you guys there.